just stared at a blank screen, knowing what you need to code, but you have absolutely no idea where to even start? Well, we're about to fix that. We're going to walk through a simple, but honestly an incredibly powerful template that's going to help you plan out any function for any project you can think of.
Oh, you know the feeling, right? You've got your editor open, that blank file is just staring back at you. The blinking cursor is practically mocking you. The problem feels so big that you can't even figure out the first step. Your mind just goes totally blank. It's a huge frustration, and trust me, it happens to everyone.
Yep, that feeling, it's got a name, coder's block. But here's the good news, there is a proven way to beat it. And it's not about writing more code, it's about thinking before you code.
So what's the solution? Well, you've got to create a blueprint for your code before you even think about building it. And then this blueprint, it's called Pseudocode. It's the absolute key to turning a really complex problem into a simple step-by-step plan. Now, don't get thrown by the name. Pseudocode isn't some new complex programming language. It's just you writing down the logic in plain English. Think of it like a recipe, right? You wouldn't just start throwing ingredients in a bowl without knowing the steps. Code is exactly the same. And this right here, this is the core idea behind this whole process. If you can clearly explain what you're starting with, what you need to end up with, and the steps to get there, all just using your own words, well, then turning that into a language like Python becomes so much easier. Okay, so how do we actually build this blueprint? The whole process kicks off with a simple 3-step plan. This part is all about defining the problem and outlining our solution. So let's get right into it. These first 3 steps, think of them as laying the foundation. First, we're going to restate the problem, just to make sure we actually get it. Then, we'll define what our little function is going to do. And finally, we'll map out how the main program is going to use it. Let's break them down.
Step 1 is, you gotta hear me on this, it is so critical. Restate the problem in your own words. Just ask yourself, okay, what information am I starting with? Those are your inputs. What result do I need to produce at the end? Those are your outputs. And then the big one, what's the process that turns those inputs into those outputs?
Next up, you just sketch out the function. And listen, don't worry about perfect syntax here. That is not the point. Just give it a name, list the data it's going to need, those are the parameters, and then in plain English, just list out the steps. What's the first thing it needs to do, then what's next, and finally, what's it going to return at the very end. And step 3 is where we kind of zoom out and look at the bigger picture. How is this function actually going to be used? You'll need to get some input values from somewhere, call the function you just planned out, probably store that result in a variable, and then do something with it, like print it to the screen. So you've got a plan. That's awesome. But is it a good plan? The next 2 steps are all about quality control. We're going to test our logic before we've invested a single minute writing the actual code. This is where we get proactive. We're going to think about everything that could go wrong. We call those edge cases. And then we're going to mentally test our entire logic with what's called a dry run. I mean, this is the question that haunts every single developer. What if the user enters some really weird data? What if a value is just missing? What if the input is 0 when you were expecting a positive number? Planning for this stuff ahead of time, that's the sign of a great programmer. So, step 4 is all about actively thinking about those tricky situations or edge cases before they have a chance to become bugs. It really is all about anticipating problems. For example, what happens if your function gets a 0, or an empty string, or just totally invalid data? Now, the crucial part here is that you don't actually have to solve these problems in your pseudocode. You just need to make a note of them. Just being aware of them is the first huge step. And now for the final step in our planning phase. The dry run. This is where you literally become the computer and you execute your own pseudocode right in your head. It's a super low-cost, high-value way to catch logical mistakes really early. And the process is so simple. Just take some sample data, let's say the number 5. Now walk through your plain English steps. What happens at step 1? What happens at step 2? And at the very end, does the result you get in your head match what you expected to get? If it does, your logic is solid. So, after all these steps, what's the one big idea you really need to remember? It all boils down to a very simple golden rule for writing effective code. It's this quick checklist. Before you write a single line of actual code, you should always be able to answer these 3 questions. What are my inputs? What are my outputs? And what is the process that connects them? If you know these, I'm telling you, you can code anything. And that's really the ultimate takeaway. This isn't just some template, it's a whole mindset. Programming is a thinking activity first and a typing activity second. If you master the thinking part, you will spend way less time debugging your code later. By following this simple 5-step process, you're not just writing code anymore, you're actually engineering solutions. You now have a repeatable plan to tackle any problem that comes your way. So I guess the only question left is, what are you going to build now that you have the blueprint?